So 2.2, the factor theorem. What is the factor? We did the remainder theorem, now it's factor theorem. You know, when a number like 24, right, we have 24. I know 2 is a factor of 24. Why? Because if you divide 24 by 2, 1 multiplied by 2 is 2, minus 0, 4 here. 2 multiplied by 2 is 4. See, the remainder is what? 0. If 2 is a factor of 24, the remainder will be 0, right? Now, just having that in mind, you know, if you divide px by x minus b, you know the 0 here is x equal to b. Then p of b will be equal to remainder, according to the remainder theorem. Since I know x minus 1 is a factor of that, I know remainder going to be 0. So therefore, p of b going to be 0. The same thing's here. If you, if ax minus b is a factor of px, you know the 0 of ax minus b, bring the b to the other side, divide both sides by a. So it's going to be x equal to b divided by a. Therefore, PB over A is equal to remainder. Since this is a factor, I know the remainder is going to be 0. So PB over A is 0. So this is factor theorem again. So I want to check if the x minus 2 is a factor of that. So I know the 0 here is 2. I'm going to check P2. P2 is 20, is not 0. Therefore, x minus 2 is not a factor. I'm going to check if x plus 2 is a factor. I know 0 of the x plus 2 is x equal to negative 2. I need to calculate p of negative 2. We see that p of negative 2 is 0. Therefore, we can say x plus 2 is a factor. Any question?
No.
So the next thing is factor this. x3 plus 2x2 minus 5x minus 6. First things I need to know is I need to guess a factor. You have to look at the constant. This is the first step. The constant is negative 6. I need to write all factor of negative 6. What is it? It's plus minus 1, plus minus 2. So 2 is a factor of 6, plus minus 3, and plus minus 6. Then I need to try one by one to see which one is a factor and not. For example, I'm going to try 1, right? I find a P1, so it's not 0. So 1 is not a factor. I try P2. I calculated, see is 0. If P2 is 0, means x minus 2 is a factor. Does that make sense? Now, what I do, now I know the x minus 2 is a factor. I'm going to do the long division. For the long division, we have, I did taught to you, I'm not going to repeat that. This is the long division. So you do it. We expect the remainder to be 0 because x minus 2 is now as a factor. Therefore, dividend equal to what? X minus 2 multiplied by quotient. See, x minus 2 multiplied by quotient is equal to dividend. Then x power 2 plus 4x plus 3, it's fact. You need to write that one in a factor. This is easy. You just need to not need two number that if you add is 4, and if you multiply is 3. So what is that number? So it's 1 and 3. Yeah. Therefore, the factor of this is x plus 1, x plus 3. Go back to the method of the factoring that you learned in grade 11. So x power 2 plus 4x plus 3, you can write it as x plus 3, x plus 1. X minus 2, you got it from the previous step. Did you understand? Any question? This is how we factor. So this is another example. When the highest power is 4, you have to apply twice the factoring. You have to apply twice. First, you look at the constant. You write all possible factor of 18, which is 1, 2, 3, 6, 9, and 18. Then you try one by one to guess one factor. So let's say we try x -1, so p -1 is 0. So -1 gonna be a factor. If the x equal to -1 is a factor, means x plus 1. You have to try x plus 1 is one of the factors, right? So your polynomial, you divide that by x plus 1, you get the answer by doing it. Then this one, your dividend is equal to the divisor multiplied by quotient. As you see, this one is your divisor multiplied by the quotient. But I need to apply another factoring for this and write it in a factor form. I take that here. Again, I'm looking at the constant, write all possible value that is factor of -18. We need to guess. We try x equal to -2. P of this one gonna be my P now. P of -2 is 0. Therefore, we say yes, x equal to -2 is a factor. Then I'm doing the long division for that. So you take the expression divided by x plus 2, we do the long division, we get x power 2 minus 9. Now this is, again, your dividend is x plus 2 multiplied by x power 2 minus 9. See, we do it. This is x plus 1 is from the previous step. For this step, we have x plus 2, x power 2 minus 9. I hope that you remember that. You need to, this is a power 2 minus b power 2. The difference between the squares, you can write it as a factor form. It's going to be a minus b, a plus b. The same way you can do for x power 2 minus 9. Instead of the 9, I can put 3 power 2, right? So it's going to be x minus 3, x plus 3. So instead of the x power 2 minus 9, I put these two, x minus 3, x plus 3, and I'm done factoring. Any question? Theodore, did you understand?
Yeah.
Okay. So here is, okay. Sometimes, so this expression, again, I want to write in the factor form. Sometimes the highest power has coefficient. In previous example that we did, see the highest power doesn't have any coefficient, true? It's a little bit different, but not that much. So what we need to do, we take this one is, right, is 2. All possible factor of that is 1 and 2. And 3, all possible is 1 and 3. So the guessing gonna be 1 over 1 here, 1 over 3, 2 over 1, 2 over 3. So these are the possible factor I need to check. Let's say I'm checking P1. So I get 0. So this is one possible factor. Again, if the P1 is 0, so x minus 1 gonna be a factor. I do the long division and I get that. When I get that, I have to write this one in a factor form. For 3x2 plus 5x minus 2. I need to find two numbers that if I add equal to 5, this one. And if I multiply these two numbers, should be multiplication of these two. -2 multiplied by 3 is -6. So what is this two number then? As you know, it's gonna be -1 and 6. You do that, right? So the number gonna be -1 and gonna be 6. But since this has a coefficient, I need to divide both by 3. Simplify -1 over 3. And this one gonna be what? 2. So for this one, it's gonna be x. In numerator, we have what? -1. Because the denominator is 3, this denominator need to go to the coefficient of the x. For this one is simple. There is no denominator, it's just x plus 2. So now instead of 3x2 plus 5x minus 2, I put 3x minus 1, x plus 2. See, 3x minus 1, x plus 2. You need to know how to factor a quadratic from grade 11. But still, if you have question, I can answer. Do you have any question? Okay, I'm gonna go to the worksheet and I tell you what questions to do. So this is this is remainder theorem actually, right? This is the one that I kind of told you. Let me just open the right ones. This is remainder theorem. Factor theorem worksheet. Okay. Do you see the factor theorem worksheet? Together?
Yeah.
I want you to, I want you to do question 1. Make sure when you do the question, for example, P4 is 0, means x minus 4 is a factor, right? So you have to tell me what is that factor. Determine if this is a factor of each polynomial. So number 2. Number 3, C. Okay. Number 3, C. Number 8, 9. Yeah, you got it?
Yeah, I got it.
Okay, perfect. I'm gonna just pause the recording.